Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 25 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3394. Check if grid can be cut into sections. Okay, so this problem is actually very easy. I'm not going to say that this is of medium level. It's very easy. You have to just find out one logic here. Okay, so let's read the problem statement first. You are given an integer n representing the dimensions of n into n grid with the origin at the bottom left corner of the grid. Okay, so like if suppose this is my rectangle. Okay, so this is going to be the starting point. Okay, bottom left corner. So this is the starting point. You are also given a 2D array of coordinates rectangles where rectangles of I is in the form start of x. Okay, here I can write a start of x and then start of y given to us, start of y, and then we have given end of x. So here we have given end of x and end of y. Okay, like this. All right, end of y. All right, representing a rectangle on the grid. Each rectangle is defined as follows: start x, start y, the bottom left corner of the rectangle. Okay, bottom left corner of the rectangle, and x and y, the top right corner of the rectangle. Top right corner of the rectangle. Okay, note that the rectangles do not overlap. Your task is to determine if it is possible to make either two horizontal, okay, two horizontal or two vertical, okay, two vertical cuts on the grid such that each of three resulting sections formed by the cuts contains at least one rectangle. Okay, so if you are cutting like this, okay, two sections, so here there should be one, at least one triangle. There should be at least one triangle in between. There should be at least one triangle here. Okay, same way in vertical, there should be at least one triangle here. There should be at least one triangle here. There should be at least one triangle here. Okay, right? Each rectangle belongs to exactly one section. Okay, we have to return true if such cuts can be made, otherwise we have to return false. All right, now see this example number 1. Okay, n is equal to 5 and these are the rectangles. So 1 5, okay, 1 and 5 is the starting point. Okay, so here if you see here, so 1, okay, and the 5 is the ending point. Okay, so here you can write see it like this. We have given like start x and start y. Okay, so this is start x, start y. So 1 0. Okay, 1 0. So let's say this is rectangle A. Okay, so 1 0. Okay, so this is nothing but 1 0 and this is nothing but 5 2. Okay, so this is nothing but my rectangle A. All right, 1 0 coordinate, right? 1, x-axis 1, and here in the y-axis 0, and same way here in the x-axis 5 and in the y-axis 2. Okay, so 1 0 5 2, right? This is given A. Now see this rectangle, let's say B. Okay, so 0 2, so here 0 2. Okay, so this is my rectangle B. Okay, let me use this pencil. Okay, so this is B. Okay, 0 2, okay, this coordinate, and 2 4, 2 4 here. Okay, then see this rectangle C, 3 2, 3 2. Okay, so this is a rectangle C, starting is 3 2 and ending is 5 3, 5 and 3 here. Okay, now here this, let's suppose rectangle D, 0 4, so here starting ending at 4 5. Okay, so this is rectangle D. Okay, so now see here, I can easily make three cuts here, na? One here, one here. So all the three sections, okay, section 1, let's say, section 2, here this is section 3. So all these sections contains at least one rectangle. Okay, here we have 2, okay, here we have 1, here we have 1. Good, right? So return true if this is possible. Okay, same way for the vertical case also. Here see, one section, second section, and 3 section. Okay, so in each section we have one, at least one triangle. Okay, one here, and here 2. Okay, so in this case we are also returning true. Okay, so now this is clear how we are returning the output. Okay, now how you guys are going to solve it. Okay, so that is also very easy. Okay, so here first of all, uh, this, what is this representing? This representing the starting point, okay, in x-axis. Okay, this one, right? Then this 0. Okay, so we have one x-axis, let's say this is x-axis. Okay, and now here let's say we have numbers like this 0 1 2 3 4 5. Okay, let's say we have numbers like this. Okay, so now here, first of all, let's suppose if I sort them based on their starting point. Okay, this like this 1, this 0, this 3, this 0. Okay, based on them. Okay, so first this will come, right? 0 to 0, 0 will come. Okay, so here if you see, this is the starting of x, right? And where is the ending of x? Ending of x is at 3 index. Okay, so now take in consideration these 2 points. Okay, 0, okay, this 0 and this 2. So this is nothing but the start and this is the end. Okay, so in 1D, how I'm going to represent this? First this will come now based on their starting. 0 is starting, so 0 and 2 is end. So this is how I can represent in one dimension, right? So here see, uh, starting from 0 and ending at 2. Okay, so there is one rectangle, okay, in this plane region. Okay, 0 to 2. Okay, same way then 0 to 4 will come. Okay, 0 to 4 will come here, 0 to 4. Okay, then after that this 1 will come, 1 to 5. Okay, so here I'm going to write 1 to 5. Okay, then after that 3 to 5 will come. Okay, so 3 to 5 will come. Okay, so here there is no common point in between. Okay, so this is ending at 2, but see this there is no other rectangle which is starting from here. Okay, but see this is crossing it, so definitely we can't split from here, right? Because this is crossing it. Same way I can't start from here because this is crossing it, so this is, we can't split here, so there is no point. Okay, in the horizontally we are not splitting, right? Okay, so we are not splitting this vertically, right? So if I'm making cuts like this, okay, like this, so vertically is not possible. So now let's see horizontally. So horizontally, for horizontally you can do one thing now. Horizontally you can start from this, you can sort based on this point. Okay, this start of y, based on start of y you can again sort. So this, okay, so here give number 0 1 2 3 4 and 5. Okay, so first uh, this is 0 na? So 0 to 5 there is 1. Okay, so 0 to 2, sorry, 0. Now see these 2 points. Okay, initially we were taking index 0 and 2, now we have to take index 1 and 3. Okay, so 0 2, so 0 to 2 here, this is nothing but a rectangle A. Then here 2 to 4 we have a B. Okay, so 2 to 4 here I can make B. Okay, then here 2 to 3 we have C, so here I can make 2 to 3 C. And then we have 4 to 5 D. Okay, so now here you can easily make one split here, right? Because no rectangle crossing, okay, this line. So this one is starting from here and one is ending here. Same way you can also draw one line here, because one is ending here and other ones are starting from here. Okay, so this is what how you can find it. Okay, so now, so first thing, for this on the x line, okay, you have to sort the array based on this point, start of x. Okay, based on start of x. For vertical line you have to sort the array based on the start of y. Okay, and then once you have sorted, so then what you need to do, what you need to check here, so you have to check the ending point of this. Okay, and if the ending point of this is if the ending point of this, okay, and here the same, here the starting point, okay, of the next rectangle. Okay, so ending of this and the starting of this rectangle, if they are both at same location, okay, and ending of this and start of this, okay, if they are in same position or maybe start coming from top, somewhere from top, okay, then definitely we can split that section. But if end is here and the start of the next is here, then we can't split from there, right? Clear? So this is what we need to do, right? Same way here. So see, this is the end of this, but the start of the next one is from here only. Okay, right? So this is what we need to do. Okay, so let's suppose this is my horizontal line. So first rectangle comes like this. Okay, let's say 0 to 5 first is coming. Okay, so 0 to 5. So right now my max end, okay, max end variable, it stores the max ending. Okay, first we are going to sort them based on the starting now, so definitely this point A is coming first. Okay, then B. Okay, so max end, let's say 5 here. Then let's suppose next rectangle is starting from here. Let's say this is C point of the start. Okay, so we have to sort them based on start now in this horizontal line. So next is C. So here I will check now, start of C is not greater than or equal to max of end. So if I want to split this section, so next start should be somewhere here or maybe from here, okay, from any other point, but it should not be before this max end. Okay, so in that case split is not possible. But if the C start from here, let's say, then split is possible, C and D. Okay, then split is possible. So this is, but it's very normal, right? So now let's write the code, very simple code. Okay, not tough. So now here, first let me just maximize the screen. Okay, okay, I hope that now screen is clear. Okay, you are able to see the code now. Int length, okay, just calculate the length. So here rectangle dot length, and then we have to sort by x1. Okay, we have to sort our array by this position. Okay, start. Okay, so here I will write arrays dot sort, and what we are sorting, we are sorting our rectangle arrays. Okay, and here let's suppose we have two parameters a and b. Okay, we have two rectangles. Okay, so let's say this is my a rectangle and this is my b rectangle. Okay, so how I'm going to sort them, I'm going to sort them based on their first index. Okay, because at first index we have starting of x, right? So here integer dot compare, and here I have to write a of 0, and here I have to write b of 0. Okay, this is done. All right, so now I have sorted the array. Now initially let's take the max end at max end of the first array na? We have to take the max end of the first rectangle. Okay, first starting rectangle. So here that is nothing but max end will be at, if you see, max end will be at this index. So this is 0 index, this is 1 index, this is 2 index, at 2 index. So here max end is equal to rectangles. Okay, and here you have to write 0 and here you have to write 2. That's it. Okay, now we have to count the number of splits that we can do vertically. Okay, for the horizontal line we have to do the splits vertically, right? So this is done, and then you have to, let's start from the next next rectangle. Let's start from here. So for this I will compare, what I will compare, I will compare the start of this with the max end. Okay, so if the start of this is greater than or equal to the previous max end, then definitely split is possible. But if it is not, if C is from here, okay, then split is not possible, right? So here I'm going to run one loop, int I is equal to 1, and here I is less than length, and here I plus plus. Okay, and here we have to check if rectangles, okay, so start of the next rectangle, b rectangle, okay, if it is greater than equal to the max and previous end of the previous rectangle. Okay, so if that is the case, then count plus plus. Okay, and otherwise we have to just update the max end. Okay, max end is equal to math dot max. Okay, and here we have to pass max end, and here we have to pass rectangles. Okay, and the current max end of the new b rectangle. Okay, so I, and at 2 we have that. Okay, so why I'm writing updating max end every time? Okay, so simple now. So first rectangle, okay, this is first rectangle starting from a to b. Okay, here then there was next rectangle which was starting from here, b to c, and b to, let's say, a to b, and this is c to d. Okay, and after that there is one more rectangle which is starting from here. So now you will say that there is one split possible, but no na, because this rectangle is also cutting na, so split is not possible. So we have to always update the max end. Okay, so now we have to check here for this one. Okay, but it is not possible, right? So that's why we have to always update max end. Okay, so this is clear, done. And here you have to simply check if your count becomes greater than equal to 2. All right, and then in that case return true. That's it. Okay, this is by sorting by x1. Now sort by y1. Okay, so again what you need to do, again you have to copy this. Okay, copy this, and same thing for y. Okay, so here arrays dot sort rectangles a b, and here we have to compare based on the first index, that is the start of y. Okay, this is done. Then we have to update the max end. Okay, now this time max end is at 0 by 3. Okay, So max end is at 03 now. Here max end is 03. Okay, this is done. Okay, so you have protected this, then you have to update again, start the count. So count, I will just create count is equal to 0. Then again you have to run one loop. So here this time you have to compare this start, okay, start of y I1, and if it is greater than this, and here I of 3 instead of 2, I of 3 you need to do. And here same, if count becomes greater than equal to 2, then you have to return true. Okay, and otherwise you have to simply return false. Okay, if we don't execute true anywhere, then simply return false. That simply means it is not possible. Okay, now let's run the code. Okay, so there is some issue here. It's a spelling mistake. S should be there, rectangles we have, right? So let's run it again. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.